See the first question. Matter waves are generated due to the motion of option A only charged particles, option B only neutrons, option C both charged particles and neutrons, option D electrons, option C both charged particles and neutrons is correct because when the neutrons are in motion, matter waves are generated. But as far as the electromagnetic waves are concerned, they are generated only when the charged particles are in motion. Now see the second question. Matter waves are option A electromagnetic waves, option B a special type of wave, option C square waves, option D radio frequency waves. Option B is correct because electromagnetic waves are generated only when the charged particles are in motion. But matter waves are generated even though a neutron is in motion. Therefore, it is a special type of wave. See the third question. The wavelength of a particle of mass m moving with velocity v is lambda equal to h divided by mv or h by p. Both are correct. If the mass of the particle is infinity, the value of the de Broglie wavelength is 0. In this relation, lambda equal to h divided by mv. If m equal to infinity, then lambda equal to h divided by infinity into v. Anything by infinity, 0. If v equal to 0, then lambda equal to infinity. If v equal to infinity, then lambda equal to 0. Therefore, matter waves are generated only when the particles are in motion. See the fifth question. The de Broglie wavelength in terms of energy is option C. You know that kinetic energy E equal to half mv square. This is equal to m square v square by 2m. Then m square v square equal to 2me. This is p square because p equal to mv. From this p equal to 2me inside the root. Lambda equal to h by p, which is equal to h divided by 2me inside the root. So option C is correct. The wave velocity of the de Broglie wave is option A, u equal to c square by v. You know the value of E equal to h nu, energy of the photon. Then according to Einstein mass energy relation, E equal to mc square. From these two relations, nu equal to mc square by h. Then de Broglie wave velocity u equal to nu lambda. Then u equal to mc square by h into the value of lambda is h by mv. This is c square divided by v. The wave velocity of the de Broglie wave in terms of wavelength, you know that E equal to h into nu. Therefore, nu equal to E by h. E equal to half mv square by h. This is equal to E into V. V is the potential, E is the charge. Half mv square is equal to E into V divided by h. Now take the relation nu equal to E into V by h. This is modified as h by 2m into 2m by h E capital V by h. which is equal to h by 2m, 2m e capital V divided by h square. You know that de Broglie wavelength associated with an electron is h by 2m eV, small e, charge inside the root. Therefore, we may write nu equal to h by 2m into 1 by lambda square. This is our 1 by lambda square, because lambda equal to h divided by 2m eV. Now, velocity of de Broglie wave equal to u suffix d equal to nu lambda, then h divided by 2m into 1 by lambda square into lambda, which is equal to h divided by 2m lambda. Therefore, option B is correct. Now, the phase velocity of the de Broglie wave is option C, Vp equal to omega by k. Among the points given below, which one is not correct? See the first point, the velocity of matter waves depends on the velocity of the particle. This point is correct because u equal to c square by v. Option B, the smaller the particle, the greater the wavelength of the matter wave. If m is equal to small, lambda is large. This is also correct. See the third point, the velocity of an electromagnetic wave is constant. This is also correct. See the fourth point, the velocity of the de Broglie wave is less than the velocity of light. This is not correct. So option D is our answer, because the velocity of the matter wave is equal to c square by v, greater than the velocity of light. The de Broglie wavelength associated with electron is, we know that lambda equal to h divided by mv, half mv square is equal to e into v, mv square is equal to 2 into ev, m square v square is equal to 2m ev, m into v equal to 2m ev inside the root. Therefore, lambda equal to h divided by 2m e into v. If you put the rest mass of the electron and charge Planck's constant value, we may get our relation lambda equal to 12.26 divided by root v. Here v is our potential, Armstrong unit. So option B is correct. The de Broglie's wavelength associated with an electron accelerated by a potential of 100 volt is, use the formula, lambda equal to 12.26 divided by inside the root v. So we have to put 100. Root 100 is 10. So the answer is 1.226. Option B is a correct answer. See the 13th question. Single particle motion in quantum mechanics is represented in terms of wave packet. Wave packet is an envelope which carries a number of waves. They may produce constructive as well as destructive interference. Finally, the entire wave packet may move with one particular velocity called group velocity. Here Vg equal to V. Velocity of the particle is equal to group velocity. The velocity of the wave packet is group velocity. If you think about the velocity of the individual waves, that is phase velocity. The velocity of the wave packet is called group velocity. On the basis of wave packet, particle velocity equals group velocity. A relationship that connects wave velocity and group velocity is, that group velocity Vg equal to d omega by dk. Take this relation B, Vp equal to Vg minus k into dVp by dk. Then Vg equal to Vp plus k into dVp by dk. Vg equal to d omega by dk. Therefore, d omega by dk equal to Vp plus k into dVp by dk. So these two relations are taken as B and C. So both B and C are correct. For a non-dispersive wave, the value of dVp by dk is 0. If it is the case, then Vp equal to Vg. Because dVp by dk is 0, if dVp by dk is 0, then Vp equal to Vg. Vp equal to Vg. Phase velocity equal to group velocity. As far as a non-dispersive wave is taken, Vp equal to Vg. Since the value of dVp by dk is 0. For a dispersive wave, the value of dVp by dk is non-zero. In this case, Vp not equal to Vg. The value of phase velocity is omega by k, E by p, p by 2m, half into v, all the above. Omega by k equal to 2 pi nu. Then the propagation vector k is replaced by means of 2 pi by lambda. See this relation, E by P. We know the value of E. E equal to h nu. Actually, we may get nu is 2 pi cancel. This is h by mv. Instead of this lambda, we have to put h by mv. So h divided by mv. H nu is our energy. E by P. We can get this second relation. Then for a free particle, energy is P square by 2m whole divided by P, which is equal to P by 2m. We can get this relation. P equal to mv divided by this 2m, which is equal to 1 by 2 into v. So this is also correct. So the answer is all the above. In the case of electrons, particle velocity strongly depends on wavelengths, propagation vector, either A or B, none of the above. Here V is inversely proportional to lambda, but the propagation vector is directly proportional to velocity. We know that k equal to 2 pi by lambda. Therefore, either A or B is correct. The concept of wave nature is suitable for a particle with momentum of the order of, we know that lambda equal to h by mv. H is expressed in terms of 6.6 into 10 power minus 34 joule second. Mass of the electron 9.1 into 10 power minus 31 kilogram. Velocity of the electron is 1 by 10th of the velocity of light. Therefore, it is expressed in terms of 10 power 7 meter per second. momentum P equal to m into v, which is equal to 10 power minus 31 into 10 power 7. Then we may get 10 power minus 24. So option C is correct. Only in the atomic dimension, the concept of matter wave is suitable. The value of the energy of a particle in a relativistic case is what? Further, take the relation variation of mass velocity m equal to m0 divided by 1 minus v square by c square. Squaring on both sides, we can get m square equal to m0 square divided by 1 minus v square by c square. M square equal to m0 square divided by c square minus v square into c square. This is m square c square minus v square, which is equal to m0 square c square. M square c square minus m square v square equal to m0 square c square. M square c square is equal to m0 square c square plus m square v square. Multiply both sides by c square, we can get m square c power 4 equal to m0 square c power 4 plus m square v square c square. You know that p equal to mv and e equal to mc square. Then this is e square equal to m0 square c power 4 plus p square c square. Then e equal to root of p square c square plus m0 square c power 4. So option B is correct. The Davison and Germer experiment relates to electron diffraction. Davison and Germer's diffraction experiments target material was nickel. At what angle can the Faraday cylinder move on a circular scale to receive the reflected electrons? Between, these are all, and between 20 and 80 degree. This is a correct answer. The interatomic distance of nickel is 2.15 into 10 power minus 10 meter. In Davison and Germer experiment, for an electron accelerated with a potential of 54 volts, the diffraction angle is 50 degree. Option B. The value of interplanar distance for nickel crystal is option B, 0.909 into 10 power minus 10 meter. See, D equal to 2.15 into 10 power minus 10. This is our interatomic distance, sin 25 degree. So we may get this value. An electron's wavelength when accelerated by potential of 54 volts is, use this formula, D equal to A sin theta. Here we may get the interplanar distance and use the Bragg's diffraction formula 2D sin theta equal to n lambda. Here we have to use the value of theta is 90 degree minus 25 degree. Theta is the angle between the incident beam and the interatomic planes in this diagram. If you substitute all the values, we may get lambda equal to 1.65 Armstrong unit. Suppose we use the formula lambda equal to 12.25 divided by root 54, root V. Instead of V, we have to put 54. We can get the value of 1.67 Armstrong unit. The de Broglie wavelength associated with a proton moving with a velocity equal to 1/20 of the velocity of light is 2.64 into 10 power minus 14 meter. See here, velocity V equal to 1 by 20 into velocity of light. Velocity of light is 3 into 10 power 8. So this is 1.5 into 10 power 7 meter per second. We know the mass of the proton 1.6 into 10 power minus 27 kilogram. Wavelength lambda equal to h divided by mv. This is our Planck's constant 6.6 into 10 power minus 34. Mass is 1.6 into 10 power minus 27. Then velocity equal to 1.5 into 10 power 7. If you simplify this, we can get lambda equal to 2.64 into 10 power minus 14 meter. The energy of a neutron with a de Broglie wavelength of 1 angstrom unit is 8.13 in 10 power minus 2 electron volt. To find out this, we know the formula lambda equal to h divided by 2me. This is the wavelength in terms of energy. We need the energy value, so square it. Lambda square equal to h square divided by 2me. Then E equal to h square divided by 2m lambda square. H square 2, this is the value of m. Then the given lambda is 1 angstrom unit, so 10 power minus 10 square. If you simplify this, you can get 13.04 and 10 power minus 21 joule. To convert the joule into electron volt, we should divide the value by 1.6 into 10 power minus 19. Then we may get 8.15 into 10 power minus 2 electron volt. In the option, they have given 8.13, so A is correct.